In this mechanical structure, we have a red ball at this height and with initial zero speed, rolling along a frictionless surface and getting into the inside of a circle and rolling from point B to point T on top and then rolling out. We want to find the speed of this red ball when we get to point B and point T, and also the corresponding surface force that is exerted on the ball. To do that, we rely on conservation of energy, which says the delta in potential energy, which is mgh, is equal to the delta in kinetic energy, which is m times v squared divided by 2. Bear in mind that at the beginning there is no speed, v is 0, we are at the maximum height, but when we go back to point B and then go on top at point T, the h is reduced by 2/3 of d. So that is the reduction in potential energy, which is translated to increase in kinetic energy. So basically at point top or T, what I can say is delta mgh is equal to mg and delta h, which is, as you can see, delta h when point red ball gets to this point is the drop of 2/3 d. So we have 2/3 times d equal to delta mv squared. Given the initial speed is 0, so delta mv squared is just m/2 times v squared on top. M cancel out from both sides, so therefore we get v squared on top is equal to 4/3 g times d. So let's keep this as equation number 1. We're going to use this, and also I'm going to use Newton's laws of motion. So in that sense, I'm going to use the famous equation that sigma f is equal to m times acceleration. In this case, acceleration on point T is just speed at that point divided by r, assuming that the ball is rotating along the circles that is shown here. So, and the sigma f, as you can see on top, we have only two forces that we can recognize in addition to the mv squared over r, which is this force, mg, and also the force that is exerted by the surface on the ball, which is, let's say, F surface, however you want to name it. So this is the one that I'm looking for. So in this case, what I'm going to write for at point T is effectively sigma F equal to mvtr is equal to, I can say, mg plus fs. Okay, I'm going to use equation 1 here for v squared at point T. So therefore, what I can say is m over r, which r is d over 2. So I can also substitute for that. So is d over 2 times v squared t is 4/3g times d. That's for substitution of mv squared divided by r equal to mg plus the fs that I don't know on top. So in this case, therefore, as a result, what I get is, let me go back to the black color that I had. So fs on top is equal to d goes away with d, and then we have 8/3 times mg, and then minus 1 mg. So it becomes 5/3 mg. That is what we get here. Because as you saw here, we have 8/3 that shows up here, and then minus mg that gives us 5/3 mg. So at point B at the bottom, we can write the same thing. Again, let's use the law of conservation of energy, delta mgh. When the ball gets down the frictionless surface to point B, the height is 0. So delta h is the whole height you can see here. So in that case, the delta mgh is simply mg times 5 over 3. That is the sum of 1d plus 2 over 3d. So d equal to delta kinetic energy, which is then m over 2 v of the ball at the bottom squared. So again, m cancel out from both sides, and what we get in this scenario is speed of the ball at the bottom is equal to 10 over 3. And then what we have is, let's just make sure I'm not missing something here. Okay, so we have 10 over 3, and then what we have is dg. So we have this one. So let's name this as equation number, 2. And I'm going to again use Newton's laws of motion. So in this case, I can say again sigma f equal to m times v of the ball at the bottom to the power 2 divided by, again, r, but r is d over 2, r is the radius of the circle, equal to, in this case, what we have at the bottom, we need to be careful. At the bottom, what we have is this scenario. So let me move this b to here so that we can better discuss this point. Okay, at the bottom, what we have is we have mg again, but mg is downward, obviously, the gravity, the weight, and then we have, what color did I use? Okay, so we have the force exerted from surface on the ball, Fs at the bottom, so this is Fs top, this is Fs bottom, shown here. So we can write, therefore, Fs bottom minus mg. So in this case, what I can therefore as a summary write is m over substituting r is v over 2, and then we have v squared b. I'm going to use equation 2 to substitute for v squared at point B, which is 10 over 3 g times b equal to, I have fsb minus mg, fs at bottom minus mg. So what I get, again, let me change the color to say another one. So fs, so what I get is fs at the bottom is equal to mg plus this one, and as you can see, m, let me keep m, d cancel out with d, and it become 20 over 3 mg plus mg. So it become 23 over 3 mg. So we managed to find, effectively, we managed to find the force exerted on the ball by the surface at the bottom and top, and at the same time we managed to find the square of s speed of the ball at the bottom and top in equations 1 and 2. I hope that this is helpful.